All right, so today we're going to begin our look at what is called synthetic division. Now, don't let the name mess with you. This is probably one of the easiest topics we're going to do in this course. It is much more difficult to explain how to do it than it is to do it. So just bear with me through the notes, but then when you see when I start doing the examples, you're going to go, oh, okay, that's not hard at all, okay? But it looks hard because everything involved in getting this right is involved in the setup of the problem. So I really have to stress how to set up the problem. And that takes some time. And it also takes some new notation that you may not be familiar with that I'm going to introduce at this time as well. So what we're going to do is begin with synthetic division. Now, you know the word division, right? You're dividing something. That's not going to change. But synthetic, if something is synthetic, that means it's not real, right? So in other words, we're going to be performing division without doing any division. Okay? And if you think about for a second, division isn't factoring a form of division, right? You're finding the factors. Anytime you're finding factors, you're using division. So what we're going to be doing is we're going to look at how synthetic division is a method of finding the factors of polynomials that can't use the regular factoring rules. The 4 terms, they won't factor by grouping. They're not 3 terms. They're not 2 terms, etc. So synthetic division will take care of all of the rest of them. So anything that won't factor using traditional methods, you can use synthetic division on. So what we're going to do first of all, though, is I want to introduce you to a type of notation. And it's called function or functional notation. And I don't want you to freak about this because it's so easy. All it does is function notation just allows you to name your equations or name your polynomials. Okay? So that way you can know when you're dealing with what thing. And I'm going to use functional notation in the notes because it'll make it a lot easier to write. Okay? So say we have x squared plus 2x minus 3 equals 0. Okay? Or even just to take off the equals 0 part. Just say we have this polynomial. Okay? In functional notation, you would give it a name. Now what's the variable all the way across there? What's the only letter in it? An x. So this is a function in terms of x. So in functional notation, this would be called f of x. And that simply stands for some function where the variable is an x. Okay? So f of x equals x squared plus 2x minus 3. So all it does is it names it. And usually in functional notation we use an f to stand for function. You could also see it, sometimes they'll use h or g, and they use those letters because you don't see them very often used as a variable. So they're pretty much reserved for functional notation. But you can also see functional notation used to name a specific thing. For example, when you're dividing, the thing that you're dividing by is called the divisor, right? So you might see d of x. That means the divisor. Okay? Or what's the answer you get when you divide called? Do you remember? A quotient, right? A quotient. So you might call the quotient q of x, right? So you can use specific letters to name the objects, very specific objects. So you might be dividing by an f of x, dividing an f of x by some d of x, and the answer you get is called q of x, right? Divisor, quotient, and you're dividing a function. Okay, so I'm going to use functional notation for these notes because it will make your life a lot easier. And you're going to see the functional notation as well when you get into your homework. They're going to ask you to write things in functional notation, so you want to be it. But all it does is it gives it a name. Okay, so what's the name of this function? f of x. Okay, and that simply means some function where the variable is x. So what if those had been y's all the way across there? It would have been f of y, right? Now normally when you have something in front of a parentheses like this, it means multiply. But this is not multiply. This is just functional notation, right? So f of x just means some function in terms of x. So what we're going to do is, we're going to be performing synthetic division, again, which is division without doing any division. Okay? So what we're going to do is, we're going to take some function in terms of x and divide it by some divisor in terms of x. And when you do division, you get what's called a quotient, and that quotient is going to be q of x. And does everything always divide evenly? Nope. And what's it called when you have stuff left over? The remainder. So plus r. Now r is not r of x, because your remainder is always just going to be a number. In other words, it's not going to have an x in it. So it's not r of x, it's just plain old what? R. Okay? So you're going to take some function, divide it, that gives you a quotient, plus a what? Remainder. Because remember when you did long division back in the middle of, at the beginning of time, you always put plus 2 or whatever the remainder was, you just added it in at the end. So it's always going to be added in. Now if it's negative, it won't be plus r, it would be what? Minus r, yeah. So no big deal. Watch your signs. Okay? All right. So we're going to start by looking first at how these things are set up. Okay. To do that, we need to talk a little bit about proper descending order. Most of these ideas are things that you've heard before, but we need to kick them up a notch for synthetic division, because we get lazy. We learn something once and then we don't ever use it in exact, it's not the way we usually use it, so we don't even pay attention to the proper form anymore. So remember that descending order, a while ago that polynomial I wrote was already in descending order because it goes from highest exponent to what? Lowest. Yeah. Highest to lowest exponent. And it's always the exponent that you put them in order. Well, these are going to be in order. That's not the problem. But what's going to happen is you're not going to have every term represented, right? Now think about it. If you have some money in your wallet, you have a $20 bill and a $1 bill, okay? Well, how many $10 bills do you have? None. How many $5 bills do you have? None. So do you say, I got a $20 bill and a $1 bill? Or do you say, I have a $20 bill, no 10s, no 5s, and a 1? Do you list the stuff you don't have, in other words? No. Well, in synthetic division, I need to list the stuff I don't have as well as the stuff I do have. And so what we have are what are called missing terms. Okay? So say, for example, I have x to the 5th minus x squared plus 2. This is a polynomial that is in descending order. X to the 5th, x to the 2nd, and then no x's at all. So do you agree it's in descending order? Okay. And the one with the highest degree, remember that word degree? Degree is just another word for exponent, right? The one with the highest degree or highest exponent is the x to the 5th, right? So it comes first. But what should come after x to the 5th in proper descending order? But do you see that I don't have any x to the 4ths in this problem? Right? Well, if I don't have any x to the 4ths, what number of them do I have? What number represents nothing? 0. So I have 0 of them. So if I wanted to write this in expanded form, in other words, making sure to put in every term, including the missing terms, then what I would do is just use a coefficient of 0. So watch what it is. So do I have missing terms here? Yes. X to the 5th is my first term, right? The first one you just always start with. What should come after x to the 5th? How many x to the 4th do I have here? 0. So put plus 0x to the 4th. Now, in reality, 0 is not positive or negative, but most people are happier just putting plus 0 instead of minus 0. What should come after x to the 4th? Do I have any x to the 3rds up there? Nope. So I'm going to put plus what?
0x to the 3rd.
0x to the 3rd. Good. What should come after x to the 3rd? Do I have any x squareds?
Yeah.
Yes. So I'll put negative x squared. And if you want, this would be a good time also to put in all those 1s. if you're going to go ahead and write it out so that you see every single term, you might as well put those ones there too, okay? Because you're going to need them in a minute. What should come after x squared? Just plain old x. Do I have any? So what am I going to write? Plus 0 x's. And after every x term, there's always a what? A number. Do I have a number here? Yep. So plus what? 2. What if I didn't have a number?
Plus 0.
Plus 0. Every term has to be represented, including the number term. Okay? Yes, ma'am.
Why aren't we putting a plus 1 first and then plus 2 if we're going into decision order?
Well, because you're putting them in disorder by x's.
Oh.
Don't worry about the number. Yeah, that we already had a number, right? So we just brought that number down. Okay? So it's x to the first. And that takes care of that one right there, right? So x to the fifth, x to the fourth, x to the third, x squared, x's, and then a number. Okay? So this is what proper descending order looks like. And you've probably never seen it before. Because it's usually not considered, it's pretty ridiculous to tell you what you don't have, right? But in order for synthetic division to work, I have to know what you have and what you don't have as well. Good. Okay? So, these again are called what? Missing terms. And what do you put in place of the missing terms? 0 of them. Okay? All right. So we've talked about functional notation, the names of things, and we've talked about missing terms. I've got one other thing that I need to talk about, and then we can put it all together and do the synthetic division. Again, remember, so isn't this been hard yet? No, it just takes some time to explain. So don't panic that it takes so many pages of notes for this. It's really quite easy. All right, here's the next thing we need to know. We need to talk about our d of x. Now remember that d of x is the thing you're dividing by, right? And in algebra, division is typically written as a fraction. So our d of x is the thing where? On the bottom of the fraction. It's the denominator of the fraction. Okay? Well, our d of x is always going to be in the form of x minus k. Okay? Where k is a constant, which simply means a number. The only things that are constants are numbers, okay? And I know that constant starts with a C, not a K, but this was invented by a German, and in German, there's no such thing as a hard C. If you want that K sound, you have to use a K. So it starts with a K in German, and that's why it's K here. Deal with it. All right? So, x minus k, where k is a constant. And what does a constant mean?
Number.
Just a number, right? Because 2 can only be 2 forever, right?
Yeah.
X can be what? Anything. So it's a variable, right? Yep. So a number is the only thing that can be considered constant, right? So we have x minus k. Well, I want to look at some. If I put down some divisor, some d of x's, and it's x minus k, and all I want is the k, look what happens if I want to write it as x minus k. If k equals 4, for example, then x minus k is simply x minus 4. Right? The x minus comes from here, and k is just the number. Now, we've gotten so used to thinking of the number and the sign being together, right? But when I'm using this, all I want is the k. And so I want to leave the x minus behind. Okay? And I'm going to clarify that just a little bit more too. But look what happens if k is negative 4. X minus comes from the form. And what is my k? And what does x minus 4 become? Minus a minus is always a positive, right? So this is the format that you're going to see. You're going to see these two things. You're either going to see an x minus your k or an x plus your k. Okay? And here's the way you're going to use it. Because I've got to pull that k away from the formula, I'm going to be leaving behind the x minus part. Okay? Well, here, if I leave behind the x minus, that means k is just plain old 4. But here, if it's plus, I can rewrite plus as x minus a minus. So if I leave this part behind, what does that say that my k is? Negative 4. All right? So because we're leaving the x minus behind and all I want is the k, it looks like it's changing the sign every time. And that's the way we're going to use it. If you pull your k away from an x, so it's x minus 4, x plus 4, x minus 2, x whatever, so you have an x with it, right? And we're going to take it away from that x. Remember, I want to leave the x and the minus behind, so what it's going to do is it will change the sign of your k. So if it's x minus 2, what's k going to be? Positive 2, yeah. And I always write the signs to remind myself. You don't have to, but okay. What if it's x plus 3? Then what's my k going to be? Negative 3. Okay? You pull it away from your x, and it always changes its sign. Okay? Because x plus 3, written as a minus, is really x minus a minus 3. So there's your k. Okay? So we have to leave an x minus behind. And when you do that with a plus, it's minus a minus. But you can think of it as just changing the sign. So what if it's x minus 7? What's my k?
7.
Positive 7, good. What if it's x plus 2? What's my k going to be? Negative 2. Okay? So even if you don't see the y right now, who cares? You need the usable form. What is the usable form? Change the sign. Okay? If it looks positive, you'll use a negative. If it looks negative, you'll use a positive. Okay? Now, what if I just said that k equals 5? Would I change the sign here? No, because they flat out just tell me what k is. And sometimes they'll do that. Okay? What if it says k is negative 2? Then what's my k?
Negative 2.
Negative 2, right? Don't always make it look like you have to change the sign. You only have to change the sign when you take it away from an x, right? Because you have to leave that x minus behind. Well, what would you think would happen if I put it back with its x? If it changes the sign when I take it away, what's going to happen when I put it back?
Change it.
It'll change it back, right? So, it also changes sign when you put it back. With an x. Now I'm going to give you a parallel here to kind of show you what's going on. It's not really the same thing, but a lot of students get it when you see this. If you have x minus 2, I want to solve that. I would do that by adding 2, which gives me x equals 2. So you see when I pulled the x away from the 2, what happened to it? Change the sign. But if I put it back over there with it, what would happen to it? Changes the sign. So you see you have a parallel for this. It's not exactly what's happening, but you can kind of think of it like that. The same thing happens. Okay? All right. So now we have the background. We know that f of x is simply functional notation, right? The name of your thing. We know that if you're doing synthetic division, you have to put them in proper descending order, which means we have to list not only the terms we have, but the what?
We don't have.
The ones we don't have. They're called missing terms. And we also know that if you pull your k away from an x, the k is the thing you're dividing by. If you pull your k away from an x, what does it do to it? Change the sign. What happens if you put it back?
Change the sign.
Changes the sign back. Okay? So 3 different things, kind of out there kind of stuff we wouldn't normally think of, but not difficult. Do you agree? So let's talk about the steps for synthetic division now. Easy, easy, easy. First step. Write every coefficient. What does a coefficient mean when you're talking about a term? The coefficient is which part of the term? The number part. Good. And it must include its what? Sign. Okay, don't forget the signs. Write every coefficient of f of x in a row. Now remember back here when I showed you the form for the division? F of x is the thing you're dividing by, right? Which is always the thing where in the fraction? On the top, right? So that's your f of x. That's the thing you're dividing by, okay? You're going to write all of those in a row. Do you remember columns and rows? Rows go what? Across horizontally, okay? Second, put k in a box. Now, up here, I'm sorry, go ahead and put missing terms just in case. Because you can't forget those missing terms. And remember here, if you have an x, it changes the sign, right? So don't forget that little tidbit too, because if you get the wrong sign, okay? So let's say you miss one coefficient. You didn't put a 0 where you should have put a 0. Everything you do after that's wrong. So that's half the credit for the whole problem. Let's say you get the wrong sign of k in the box. What do you think having the wrong sign of the thing you're dividing by going to do? It's all going to be wrong. So there's the other 5 points. So if it's a question's only worth 10 points and you missed 5 and 5, because everything you do after that, if you don't set it up right, then everything you do after that's garbage. So it doesn't count. Who cares if you can do the synthetic division if you can't set it up right? Yeah? So make sure you get these first 2 steps correct, or else everything else you do is garbage. Step 3. Okay? Bring down the first coefficient. Now notice I'm saying coefficient. That just means the number parts. Don't put the x's in here. If you do, that's wrong. It's just the coefficients, only the numbers. And we'll see plenty of examples of these. Bring down the first coefficient. It's never going to change. Ever. Just comes straight down. It's exactly as it was. Step 4. Now step 4 has several parts. They're easy. Multiply k by that coefficient. What coefficient? The one I just brought down, yeah. Okay? Just multiply k by that coefficient. 4b. Put that product, what's a product? Answer you got when you multiplied, right? Put that product under the next coefficient. And combine. Combine means either add or subtract depending on the signs. Sign error is about the biggest thing you can do wrong here. Right? And multiplying 2 times 3 and getting 9 or something crazy like that. Right? Because you're going to do this and it's going to be fast and you're going to get really good at it. You're going to be really fast at it. And what happens when you go fast? Make simple mistakes, right? And one simple mistake throws everything else off. Okay? Steps 4C, repeat until you run out of numbers. So you're just going to keep on. Bring down the, so you'll have your coefficient underneath. You multiply it times your k. Multiply that times your k. Combine, which gives you a new number down at the bottom. So you multiply that times your k. Combine, put it under the next coefficient, combine, and you just keep doing that until you're out of numbers. Okay? And when you run out of numbers, you're done with your division without ever having to do any division. But we still need to write our answer. Okay? So step 5, okay? The answer, which is called Q of x, why Q? Quotient, okay? Is on the bottom. So it's underneath. You'll see you're going to be drawing a line. You'll see the form in just a minute. It's going to be on the bottom. Your quotient, the thing you get your division, is on the bottom. Okay? But it's just going to be a bunch of numbers. So we got to put the x's back in. But that's easy too. It is 1 degree. What did I say a degree is another word for? Exponent. Right? 1 degree, excuse me, less than your f of x, which is the original thing you were dividing into, I'm sorry. Okay? So if the highest exponent in your original was a 5, and we do the synthetic division, the highest degree or exponent in our quotient is going to be a what? 4. Real rocket science there, right? It just goes down 1. So if the highest degree in our original was x to the 3rd, what is it going to be down in our bottom, in the answer? X to the 2nd. Okay? It's simply 1 degree or 1 exponent less than your original. Okay? The last number
This still under 5?
is the remainder. And it's probably the most important number that you'll get out of the whole thing. So it has to be right. And the only way for the last number to be right is what? If every one of them is right. Yeah? And you'll see why it's so important next time when we start using synthetic division. Now there's one more step. And that is the 2 ways to write the answer. Now, you're going to see that there are 2 different ways, 2 different formats they want your answer. The first one, they're just going to give you a fraction. Okay? And if they give you a fraction, what does the fraction bar mean to do? Divide. So you're just going to use synthetic division to divide. Okay? So, here are the 2 ways to write your fraction. First, if you start with a fraction, so in other words, the whole thing is just a big fraction from the very beginning, right? That doesn't mean it has a fraction in it. It means it's written, the division is written as a fraction, okay? If you start with a fraction, then r is a fraction. What's r? The remainder. And the fraction that you get is simply r over your original d of x. Because remember, when you're dividing, if you can't divide, whatever you have left is a fraction. Just put the remainder over whatever you were dividing by in the first place. The second one, okay, the second form looks like this. You're going to write it as f of x. Now that doesn't mean write out the whole thing. That just means use f of x equals. Then in parentheses you're going to put x minus k. Then in parentheses you're going to put your quotient of x. That's the thing you get on the bottom. And then at the end you're going to put plus r. And this one looks harder than the other one, but it's actually easy to write because everything's already written there for you. All you have to do is plunk the x minus k and then the plus r in front of what you already have written. Okay? So, pardon?
Can you
So if you start with a fraction, then what's written as a fraction? The R, the remainder. Not the whole thing, right? But just what? The remainder. But then the other times, they're going to ask you for this format, where you're just going to put your x minus k in a parentheses, your quotient in a parentheses, and then put the plus r at the end. Okay? So those are your two formats. So let's look at some examples. Again, it takes a lot longer to explain this than it does to do this. You're going to be very pleased with synthetic division. Everybody always is. But you've got to be careful, because if something looks easy, then how much time are you going to spend studying it? None. Okay, so make sure you study it. All right, here we go. We have x to the third plus 4x squared plus 7x plus 4 all over x plus 1. What does that big fraction bar mean to do? Divide. And it says specifically to use synthetic division to perform the division. Well, the thing on the top is my f of x, and the thing on the bottom is my d of x. Remember the format? Okay, the thing you're dividing by, it's always on the bottom, is your d of x. So what I want to do first is write every coefficient of my f of x. But before I start writing down any of the numbers, I want to look to see if I have any missing terms. So don't start writing anything down until you've looked at your f of x and see if you have any missing terms. We have x to the third. What should come after x to the third? Do you have any? Yep. What should come after x to the second? Plain old x. Do you have some? Yep. What should come after every x? A number. Do you have one? Yes. So in this particular one, do I have any missing terms? No. At this stage, I usually always go ahead and put those ones in as well, because I don't want letters in my synthetic division. I want only the coefficients, which means the numbers. Okay? So what is the first coefficient up there? Yeah, and I always write the signs as well, because sign errors are the biggest mistakes you're going to make in this. So positive 1. What's the second coefficient? Positive 4. Now, do I need to put the x squared in there too? Absolutely not, and if you do, I'm going to count off a point for every letter you write. And if there are 7 of them, that's almost all the points right there. All right? If you don't write it correctly, then you're not going to get the credit. What's the next coefficient?
7.
And then finally, what do I put at the end? Plus 4. Now, here's what I mean about putting k in a box. It's really a lie, because it's not k, because you're going to change its sign, and it's not even a box. It's just part of a box. It's kind of a little piece of the division symbol. That's what it looks like. But I don't want to write the whole division symbol. Now, remember, k comes from this thing, and if it's got an x in it, when I pull that 1 away from the x, what's it going to do to it? Change it. So I'm not going to put positive 1 down here. I'm going to put what?
-1.
That's the most common mistake that students make. And if you make that mistake, it's automatically -5. I'm not even going to grade anything else. I don't care, because everything else you do is nuts, just garbage, right? So get it right. Now, I told you that we're going to bring that thing down. So what I want you to do is skip a line and then draw a line. Remember what a long line like that means when you were in elementary school? It means you're adding. That's the summation line, right? Okay. So what am I going to do with this first coefficient? Bring it down. It never changes. Okay. And I always like to draw a little arrow underneath it so that I make sure that I don't put anything in that spot. Nothing can go there. We just bring down that first coefficient. It never changes. Then I'm going to take this coefficient and multiply it times my k, which is the thing in the box. So what's positive 1 times negative 1 make?
-1.
I put that under the next coefficient and then combine those two things. So what's positive 4 minus 1? Positive 3. Good. Now I have another number down there. I'm going to multiply it times my k and put it under and keep on doing it, right? What's positive 3 times negative 1? Negative 3. What's positive 7 minus 3 going to make? What's positive 4 times negative 1? And what's positive 4 minus 4 make? And you don't need plus or minus because it's zero, right? It means you don't have a number. I'm done with the division without having done any division. And my answer is this thing on the bottom, but all it is a bunch of numbers. What do I need to do now? Started off with x's in it, didn't it? So now I got to put the x's back. I started off with x to the what power? So down here it's going to start off as x to the second power. Plus 3 plain old x's, plus 4, and what's the 0? Yeah, that's the remainder, and I don't care about it, right? So my completed answer is simply x squared plus 3x plus 4. And this thing is your q of x. And you don't have to type in the q of x in your computer. All it wants is the part that's in the box there. X squared plus 3 of x, plus 3x plus 4. So do you see that this takes no time to do, but you really needed to see all that background so you can get all the setup right. Okay. Why didn't I write 0 over x plus 1? Because who cares? 0, right? It's nothing. You don't say what you don't have unless you are doing your setup. Okay. Let's look at another one. X to the fourth plus x to the third plus 2x squareds plus 4x plus 2 all divided by x plus 1. Oops, sorry about that, but well, here it is. Now, the top one is f of x, the bottom one is d of x. So first I'm going to write down every coefficient from f of x, first looking to see if I have any, what are they called? Missing terms. I have 1x to the fourth, I have 1x to the third, 2x squareds, positive 4x's, and positive 2. So any missing terms?
No.
Nope. So just write down the numbers. Positive 1, positive 1, positive 2, positive 4, positive 2. Don't I need to stick those x's in there too?
No.
Nope, and if you do, it's wrong. I'll get you for it. What goes in the box? K. K, yeah, I know. I got to take that 1 away from that x, so it's going to turn it into a negative 1, right? What if it had been x minus 1 up there? What would I put in the box? Plus 1. Good. Skip a line and draw a line. What do I do with the first coefficient? Bring it down. It never changes. Then multiply and combine until you run out of numbers. So 1 times negative 1 is negative 1. 1 minus 1 is 0. 0 times negative 1 is 0. Positive 2 plus 0 is positive 2. Positive 2 times negative 1 is negative 2. And positive 4 minus 2 is positive 2. And positive 2 times negative 1 is negative 2. And 2 minus 2 is 0. Keep giving me no remainders here. Okay? But that's not my answer. What do I have to put back in now? The variables, the x's. And it started off up here as x to the fourth, so what's it going to be down here? Plus 0x squareds plus 2x's. That's the number term, right? What's the 0 back at the end? The remainder. So when I write in my answer, it's going to be x to the third. Now, am I going to put plus 0x squareds in my answer? No. Plus 2x plus 2. And am I going to put the remainder of 0 at the end? No. So there's my cleaned up answer. Don't put the 0 stuff when you answer. Now, do I need the 0 when I'm performing the synthetic division? You bet. But do I need it when I put my answer? No. Okay?
So you don't have to put the x squared?
No, because there were 0 of them. So we're none of them. Right?
And because you changed the back onto the plus 4 and you brought up the negative 2, which it was a
Positive 2 times negative 1 made negative 2. And then positive 4 minus 2 gave me positive. Okay? Yeah. Be careful. Sign errors, the biggest thing you can do wrong here. Let's get another one. Negative 8x to the third plus 7x squared minus 6x plus 2 all divided by x minus 2. First, I need to list every coefficient of my f of x, which is the thing on the top. X to the third, x squared, x, and a number. So am I missing anything?
no.
Nope. So it's going to be negative 8 positive 7, negative 6, positive 2. Got to put my k in a box. It's x minus 2, so I'm pulling it away from an x, so what am I going to use? Positive 2, yeah. When you pull it away from the x, it looks like it changes the sign, right? Now, skip a line and draw a line. What do I do with this first term? Bring it down. It never changes. Now I'll just multiply and combine until you're out of numbers. Negative 8 times positive 2 is negative 16. Negative 16 plus 7 is negative 9. Negative 9 times positive 2 is negative 18. Negative 6 and negative 18 make negative 24, because remember the signs are the same, so you keep the sign and add. Negative 24 times positive 2 is negative 48. And negative 48 plus 2 is negative what? 46. Now this time, I didn't have any zeros and stuff up there, so I'm just going to put my x's back in and leave it right where it is. I'm not going to bother to rewrite it. Okay? But it started off as 8x to the, so this is going to be negative 8x to the second, minus 9 what? And negative 24 is your number. Well, what does that make this negative 46 business? The remainder. Did I start off with a fraction in my original? So how do I write my fraction in the answer? Over. Right. If your original problem was a fraction, then your remainder has to be written as a fraction. Now, should I put it all over x minus 2?
No.
No. I've already done this division over here, right? This part's already been divided. So the only part that goes as a fraction is the remainder. Now, when you're typing this in, would you type in the negative in the top?
Yes.
Be careful. It wouldn't be negative in the top. It'd be negative where? In front of the fraction. Okay? Don't forget the negative. Don't lose it, right? But don't put it in the top. No, because if you do that, you put that fraction bar right next to this number, that means multiply. You got to have a sign between them, or it wouldn't. Now, you could put plus and then the negative 46 on the top. Well, that's ugly. So don't do that. Well, all right? So you see the synthetic division part's nothing. The setup is everything. All right, look at this. Oops, small eraser bin. X to the fourth minus 4x to the third minus 4x squared plus 21x, all divided by x minus 3. Big fraction bar means to divide. We're going to use synthetic division to perform the division. So this setup, first thing I have to do is look at my f of x, which is the thing on the top, and see if I have any, what are they called? Missing terms. X to the fourth, x squared, x to the third, x squared, and x. Looks good to me, yeah? What's wrong with it? There's no number term, so I have to put plus 0. Your missing term can be the number. So be really careful about that, because you don't want to think of it as being the number, but it is. It has to have every term. So it's going to be positive 1, negative 4, negative 4, positive 21, plus 0. Okay? What am I going to put in the box?
3.
Yeah, it's x minus 3, so I'm going to put positive 3 in the box. Because if you pull it away from an x, it changes the sign. What do I do with the first term? Bring it down. Positive 1 times 3 is positive 3. Minus 4 gives you negative 1. Times positive 3 is negative 3. Minus 4 is negative 7. Times positive 3 is negative 21. Plus 21 is 0. 0 times 3 is 3. And 3 plus 0 is positive 3.
0 times 3 is 0.
Oh, whoops. You guys, thank you. 0 times something is usually 0, isn't it?
Sometimes.
Unless I do it. All right. Now, there's my answer, but not in the right format. It started off as x to the fourth, so what's it going to be down here?
X to the third.
So 1x to the third minus 1x to the second minus 7x. And since both of those are zeros, do I need them?
No.
And do I even need those ones in my answer? No.
But if we put them, you're okay with it?
I'm okay with it, yeah. If you get the right answer and all you've done wrong is put in those ones, I'm not going to count that wrong. Okay? All right. Let's see if they have some of the other format. Well, here's a fun one. X to the fifth plus 1 divided by x plus 1. Why is this a fun one? There's a lot of missing stuff, right? We have an x to the fifth, so positive 1 x to the fifth. Do we have any x to the fourths? Nope. Do we have any x to the thirds? Nope. Do we have any x squareds? Nope. Do we have any x's? No. Do I have a number term?
Yes.
Yes. So I had 4 missing terms there, so I ended up with 4 zeros. So you can have more than 1 0. It's x plus 1, so what's going to go in the box? Negative 1. Bring down the positive 1. 1 times negative 1 is negative 1, which gives me negative 1. Negative 1 times negative 1 is positive 1, so that gives me positive 1. Times negative 1 is negative 1, so I get negative 1. Times that is positive 1, so I get positive 1 again. Positive 1 times negative 1 is negative 1, so I get 1 minus 1, which is 0. Okay? Put in the x's. Starts off with x to the what? Fourth, good. Then x to the third, then x squared, minus 1x, and 1 is your number term, and we don't need the 0 because the remainder of 0 means we don't have anything. Okay? How easy is synthetic division? Let's look at the other format. Now, the other format, you don't change the synthetic division at all. It's just the way you write your answer that will change, the format for your answer. And the directions look a little funny. It says express f of x in the form f of x equals x minus k times q of x. And now they didn't put the parentheses like I did, because if you stick something side by side, it means what operation? Multiply. But when you're doing it, you're going to have parentheses. Plus r, okay, for the given value of k. Then they tell you that they give you the problem. The problem is f of x, which just means the function, the thing you're dividing into, is x to the third plus 4x squared plus 9x plus 10. And they give you a little semicolon. Remember, oh no, they don't. They just give you a comma. Okay? So that means that you've got part of the problem. Then the rest of it, they say k equals negative 2. So this one starts off with it being written in a slightly different format. And they wrote your k in a different format. And they want the answer written in a different format. Okay? So here's my advice to you. First, just go through just exactly like we did before. Look to see if you have any missing terms. We have x to the third, x squared, x, and a number. Any missing terms? Nope. So write them down. Plus 1, plus 4, plus 9, plus 10. What am I going to put in the box?
Plus 2.
Negative 2.
Why negative 2?
Because they use it.
Yeah. I didn't pull it away from an x this time, did I? It just flat out said that k is negative 2, so that's what you put in the box. This is where I'm going to get you. So be careful. If they say k is something, then that's what you use. Don't change the sign always. You only change the sign if you're taking it away from an x. What happens if you put it back with an x? Changes it again, right? Okay, so be careful. All right. Let's do our synthetic division. Start by bringing down the first term. It never changes. Positive 1 times negative 2 is negative 2. Plus 4 is positive 2. Positive 2 times negative 2 is negative 4. Plus 9 is positive 5. Positive 5 times negative 2 is negative 10. Oh, they keep doing that to me. Which gives us a remainder of nothing. Okay? I've still got to put the x's in just like before. Synthetic division, that part of it never changes. It started off as x to the third, so down here it's going to be x to the second plus 2 x's, and that's the number term. And what's that make the 0? So who cares, right? Now I've got to put it in this form. So here's how you can do that. Notice I left a lot of space here because I knew I was going to do this, but you're going to have to type it into Course Compass anyway. F of x equals, Now they're going to already have that typed in for you, so don't type that in. Okay, equals. The first part they want is my x minus k. But they didn't give me x minus k. They just told me that k is 2. Well, if I'm negative 2, I'm sorry. So how am I going to write k equals negative 2 as an x minus something?
X plus 2.
X plus 2, excellent. You just put the number back with the x, but when you do that, it changes its what? Sign. This whole thing is the quotient, so I don't even have to do anything to it, but put it in parentheses. And if there was a remainder, I would write it, but in this case, the remainder was 0, so who cares? So that's what the format looks like. Put x minus k in a parentheses, then put a parentheses around your quotient. So don't make this look, I mean, it looks harder when they give you this funky form to write it in, but it's no big deal. Don't make it harder than it is. Let's get one more of those. Hopefully they'll give you one with a remainder. Okay? All right. F of x equals 8x to the 4th minus 2x to the 3rd minus 11x squareds minus an x. This time they give you a semicolon. And they say k equals 3. Semicolon or a comma. Semicolon means you're done with that idea, but you're still in the same sentence, right? It's a new idea in the same sentence. So that just means that the k belongs to this stuff, right? So, set up synthetic division. First looking for any, what are they called? Missing terms. X to the 4th, x to the 2nd, x to the x to the 3rd, x to the 2nd, and x. Looks good to me, huh? Yeah, remember, even if you have all your x's, you still have missing terms, you've got to have a number. So we're missing the number term. So it's going to be positive 8 minus 2 minus 11, what?
0.
Wait a minute. Minus 1, yeah, don't forget, I was hoping y'all would say x so I could jump on you, but you didn't. Minus 1 plus a what?
0.
0. What's going to go in the box?
3.
Yeah, why didn't I change the sign of it?
Because they gave you.
Yeah, they gave me the k. I don't have anything to change the sign of. But you only change it if you put it with an x or take it away from an x. Skip a line, draw a line. Bring down your positive 8. Positive 8 times positive 3 is positive 24. Minus 2 is positive 22. Well, I hope you all have a calculator. I'm soon going to get past the numbers I can work with. Positive 22 times positive 3 is positive 66. Minus 11 is positive 55. Positive 55 times 3 is positive 165. Thank you so much. Minus 1 is positive 164. Positive 164 times positive 3 is positive... It's 2 at the end. And a 9. Y'all going to make me do this, aren't you? There you go. Plus 0 is positive 492. Now I'm done. I've rounded out of numbers, so that means I'm done with the synthetic division. But remember that anytime you have this f of x business, they want you to write it as f of x equals blah, blah, blah. Okay? So, f of x, which they already type in for you, I need to put my x minus k. Well, they didn't give me x minus k, did they? They just gave me k. So what am I going to write down here?
X minus 3.
Exactly. If it's positive 3, then when you put it back into the x, it's going to be x minus a 3. Here's my quotient, but what's it missing? X's. Start off with x to the 4th, so down here I'm going to get x to the 3rd, plus 22x second, plus 55 x's, plus 164, and that whole thing is the quotient. So what does that mean my positive 492 is? The remainder. And you just leave it hanging out there. Do I need to write it as a fraction? How do I know I don't write it as a fraction this time? Because I didn't start off with it as a fraction. Good job. Okay? Now, in this particular one, what they do is they put the x minus and then they leave a box there. Then they leave a big box here and then a box here. They've already got the other stuff in there for you. So be careful when you're typing these in. Don't type x minus 3 in that box because they've already got the x minus for you. You're just going to type the 3. Okay? So be really careful when you're looking at these, what they want entered. They're going to do that to you. Why? Because they're evil?
Try to make it easier.
Well, try to make it easier, but what are they really trying to get you to do? Pay attention, exactly. Because what do you not want to do? You don't want, yeah, well, you don't want to mess up, but you don't want to pay attention. Nobody wants to pay attention. I want to get this thing over with and get it done. But you're going to have to slow down and pay attention. Okay? Okay. Well, that finishes our look at synthetic division. An easy but incredibly important topic. Now, what we're going to do is we're going to just practice with plain synthetic division today. That's all you're going to do is synthetic division with the two formats. Original written as a fraction, original written as an f of x equals. And then we're going to learn how to use it in subsequent classes. So as we move, we're going to learn how to use synthetic division, and our eventual goal, of course, is to use it to solve equations. Okay?